If you are a mechanical engineer or just interested in physics and wondering how can you teach yourself thermodynamics, then I have a solution to your curiosity. Hello everyone, I am Prashant of Science Eclipse, and in this video I am going to tell you that how can you teach yourself thermodynamics. My first encounter with thermodynamics was in 11th grade or say in high school, but it was a little bit of chemical thermodynamics only. The true beauty of the subject can only be experienced in mechanical engineering. So, if you are a mechanical engineer, then do watch this video till the end because I am going to give you a systematic approach to study this subject. Thermodynamics kind of imposes certain limits on human capabilities that we may not realize. For example, you cannot even make an engine which is 100% efficient or say convert entirety of your fuel into energy. You could argue that there are friction losses involved, but to a greater extent, efficiency is restricted by some thermodynamic limitations. In most of the universities, this subject is taught in third semester because the study of some related subjects like fluid mechanics, heat transfer, refrigeration, air conditioning, psychrometry, internal combustion engines, and other related subjects becomes almost impossible. Therefore, you need to get this subject straight if you wish to score A grades in other subjects. As soon as you enter in the third semester, now is the time for you to decide which is your field of interest. Basically, you have 4 choices: thermal engineer, design engineer, production engineer, or industrial engineer. And there is always IT. My experience is even if you choose IT as your career field, recruiters are likely to ask questions from a core field apart from programming. And their favorite choice of subject is generally thermodynamics. After graduation, you can always seek a master's degree in thermal engineering to get a high paying job. But for now, let's keep our discussion limited to the graduation level only. The syllabus of thermodynamics involves study of early thermodynamic devices, zeroth law of thermodynamics, study of first law, ideal gases, flow processes, non-flow processes, study of pure substances, second law of thermodynamics, Carnot's work, entropy and power cycles, etc. In this video, I will guide you to a step-by-step process of studying thermodynamics so that you can acquire a deep understanding of this subject. Both paid and free platforms are available on the internet for you to study a subject. This includes platforms like MIT OCW, but for effective study, any method would require a dedicated textbook. There are many choices available. Here is a list of my preferences. Thermodynamics, an Engineering Approach by Michael A. Boles. Thermodynamics, Concepts and Applications by Stephen R. Turns, Laura L. Pauley. And then my favorite, Fundamentals of Engineering Thermodynamics by Michael J. Moran and Howard N. Shapiro. All 3 books contain an extensive theoretical framework and discussion of theory as well as some practical approaches with a great deal of numerical problems. Out of the 3 books, Turns and Pauley is much more on the advanced side and leaves a lot for you to figure out on your own. From one point of view, this seems fine, but as soon as you study more and more and dive deep, things get messier and complicated for you to figure out on your own. And if this happens a lot, you will start losing your faith in the subject. But if you're like me who likes to struggle a lot, this book is for you. This book is published by Cambridge University Press. The remaining 2 books are amazing to study and offer extensive discussion on the subject. I have preferred Moran and Shapiro in my college. Now we need the correct strategy to understand the subject. To begin with, introduce yourself with the subject meaning. Now look for a device that needs a thermodynamic approach to study. The most common example in your household is a refrigerator, which takes heat from a lower temperature atmosphere and rejects it to the higher temperature atmosphere to maintain a lower temperature environment. This seems a little bit counterintuitive in the beginning, but in the process, your refrigerator is consuming electricity. Simultaneously, your room heater for the winters, your dream bike engine requires some thermodynamic concepts to understand their operation. Upon a close observation, you will find that everything that is happening in the devices involves 4 basic processes. This is much more of a sequence called suck, squeeze, bang, and blow. A significant proportion of the thermodynamics is the study of parameters associated with these 4 processes. To begin with, you might argue, what is thermodynamics? Thermodynamics is basically the study of 3 E's: energy, exergy, and entropy. But I like to define thermodynamics in much more resembling and simpler terms. Temperature. Anything that has something to do with the temperature requires an observation from the thermodynamic eyes. Now since we have defined the subject, now we need an approach to study the subject. I have developed a sequence of topics that you should follow to study this subject and understand it like an expert. Every subject has a dedicated terminology and a problem-solving approach. You should always adapt to that approach so that when you encounter the terminology, you can identify the domain of the problem and resolve it. For an example, consider this problem. A bar of the steel is heated up to 500 degrees Celsius from ambient and has no restrictions imposed. Find the stress induced due to temperature rise. Though the problem contains the term temperature, which is extremely common, the term stress was a big giveaway that this is a strength of materials problem. Similarly, pressure, specific volume, enthalpy, energy, closed system, etc. are the terms associated which distinguish a problem to be purely thermal. Now is the time for you to familiarize yourself with the systems and approaches to study the systems. There are two approaches to study systems in thermodynamics. One is microscopic approach and other is macroscopic approach. A deep understanding of these two approaches will be very useful for you to study fluid mechanics and other mechanical engineering subjects. Once you're done with the approaches, you will find that the system goes through certain changes and you will find yourself curious about the properties, states and processes. Specific properties are an important parameter in thermodynamics, so you should understand these properly. Now you are ready to read first law of thermodynamics. The study of first law can be divided into two parts, for closed systems and open systems or control volumes. For once, just read about the closed systems and cycles. A lot of books move to open systems or flow devices just after non-flow processes. But you should avoid that. The reason is pretty much amusing. The working fluid in devices is generally taken as ideal gas, but a lot of cycles can also work with water and other substances which can change phase, and analysis of such fluids is different than ideal gas. Hence, after non-flow process, read about phase diagrams of pure substances, in which learning about evaluation of the properties will strong arm you while tackling the numerical problems. After non-flow processes, read about flow processes and flow devices. In this section of first law, concepts like control volume analysis, in which you study about mass flow rate, and the devices in which there is a constant fluid flow are introduced. Now you will read about concepts of mass and energy conservations in this section. You will also learn about devices like nozzles, diffusers, turbines, pumps and heat exchangers, etc. Generally, transient analysis is not a part of the syllabus in most of the Indian universities and including GATE exam, but you can always cozy up to it. Now you are ready for the most misunderstood and misexplained topic of academic history, the study of second law and entropy. Entropy is a sole topic in engineering where you will forget anything about engineering and manufacturing things, but it will feel more like a pure theoretical physics. A study of entropy is followed by exergy analysis. Exergy analysis is a vital part from the perspective of engineers, and a lot of questions are asked in the GATE exam and other engineering examinations. Further chapters in the subject involves ideal gas mixtures and psychrometric applications and combustion. You can always read about advanced thermodynamic topics from the research papers, but from my perspective, this is the alone subject in whole of mechanical engineering which feels more like completed and there is nothing left. For your convenience, I have linked certain courses, reference materials and other video lectures in the description. You can check those out to teach yourself about thermodynamics. I'm soon going to start publishing weekly newsletter in which I will begin with explaining one topic from scratch to finish. The newsletter will include research news from engineering and sciences, something about upcoming career opportunities, courses and skills that will improve your resume. If you like my work, please hit like and subscribe and drop a feedback in the comment section and share this video with your friends and peers, and I will see you in the next video. Thanks for watching.